Most architects think Kubernetes is about containers. It isn't. Kubernetes exists because infrastructure eventually becomes too unstable to operate manually. It's a control system, and if your infrastructure isn't unstable yet, you may be introducing the most complicated control system in your architecture for no reason. That's what systems thinking reveals. When Kubernetes shows up in architecture discussions, the arguments usually sound familiar. Scaling, resilience, modern infrastructure. Those are reasonable goals, but systems thinking changes how we frame the problem. Instead of asking what a technology enables, we ask what system behavior needs to be regulated. Kubernetes wasn't created because containers existed. Containers already existed. Kubernetes appeared when infrastructure environments became large, distributed, and constantly changing. At that point, manual operations stopped scaling. Infrastructure stopped behaving like a collection of machines. It started behaving like a dynamic system. Kubernetes was built to regulate that kind of system. The core pattern Kubernetes implements is state reconciliation. You declare the state the system should have. 3 replicas of a service. 2 instances of a workload. A policy applied somewhere in the cluster. Kubernetes continuously compares the desired state with the observed state. Whenever they diverge, it acts. That pattern is not unique to Kubernetes. It's a classic control loop. Thermostats do it. Autopilots do it. Industrial automation systems do it. Instead of predicting every failure, the system continuously corrects drift. That pattern is extremely powerful. But it only makes sense when the system being regulated actually changes often enough to justify automation. This is where systems thinking becomes useful. Instead of focusing on the technology, we look at the forces acting on the system. For Kubernetes, the dominant force is environmental volatility. In large distributed environments, machines fail regularly. Containers restart constantly. Nodes are replaced. Workloads move across infrastructure. Once systems reach a certain size, this instability becomes normal. At that point, manual infrastructure management becomes unreliable. Kubernetes introduces automated control loops that continuously restore equilibrium. But control systems always introduce their own machinery. Schedulers, controllers, overlay networking, storage orchestration. Complexity increases because the system now contains mechanisms designed to stabilize other complexity. Once Kubernetes enters an organization, another system dynamic usually appears. Complexity moves. Without Kubernetes, complexity lives mostly in infrastructure operations and application deployment. With Kubernetes, complexity concentrates in the platform layer. Cluster configuration, networking policies, security boundaries, deployment automation. Eventually, the organization adapts. A platform team appears. Not because someone decided it was fashionable, but because complex systems naturally create structures to manage the complexity they introduce. If you step back and look at Kubernetes structurally, it behaves much less like infrastructure and much more like a distributed regulatory system. Multiple controllers observe the cluster. Each controller maintains a specific constraint: replica counts, scheduling decisions, node health. None of these components control the entire system. They each regulate a small part of it. Together, they form a set of interacting control loops, which means you are no longer operating machines. You are operating a system that continuously adjusts itself. When these elements combine, a clear behavior emerges. Kubernetes works extremely well in environments where instability is already high. Large microservice ecosystems, thousands of workloads, highly dynamic cloud infrastructure. In those environments, Kubernetes absorbs volatility that would otherwise overwhelm operations. But when the environment is relatively stable, something different happens. The control system becomes the most complicated part of the architecture. Not because Kubernetes is badly designed, but because the system it was designed to regulate never really existed. This is where systems thinking changes the architect's role. Before suggesting Kubernetes, the architect should diagnose the system. How volatile is the infrastructure environment? How frequently do workloads move or fail? How large will the runtime environment become? And equally important, is the organization mature enough to operate its own platform? Because Kubernetes is not just infrastructure. It is a platform that must be designed, maintained, and continuously operated. The goal is not to evaluate Kubernetes. The goal is to understand whether the system requires a regulatory mechanism of that scale, and whether the organization is capable of managing the platform it introduces. Systems thinking changes how we evaluate technologies. Instead of focusing on features, we look at the system forces they regulate, or the forces they introduce. Kubernetes is not primarily a container platform. It is a stabilization system for volatile infrastructure environments. If that volatility exists, Kubernetes can bring order to it. If it doesn't, Kubernetes may simply become the most complex subsystem in your architecture. And that's why the real architectural question isn't, should we use Kubernetes? It's this: does our system behave like the kind of system Kubernetes was designed to stabilize? And are we ready to operate the platform that comes with it? This is systems thinking for architects.